Alright guys, let's look at lesson 6, which is organic reactions. So, how organic molecules formed are going to be determined by organic reactions. So the first one is a combustion. That's when an alkane is burned in the presence of oxygen to produce carbon dioxide and water. O2 is always a reactant, and these should look familiar to you because we saw these when we did types of reactions way back in the beginning of this semester. Number 2 is a substitution reaction. That's similar to a single replacement. Two atoms switch. So the first compound is going to be saturated. It's going to have single bonds. And the one H is switched with one of the halogens, group 17. So if we look at this, we have a CH4 plus Cl2. And one of the H's and the Cl switch. And then we get HCl as the second one. The next one is an addition reaction. That's when a double or triple bond is broken and two or more atoms are added. So the molecule must be unsaturated, so that means it has to be an alkene or an alkyne. So in this, we have an alkene, we have ethene, and that's going to react with bromine, and we're going to make this compound. So what happens is the bromines are going to go, and they're going to be added onto each side of the C's, breaking that double bond and making it a single bond. Esterification, that form smells. It's identified the ester as a product. We have to use table R to do that. So if we're looking at this, that's a carboxylic acid. We're going to add an alcohol to it, and we're going to make an ester. Remember, an ester, this is the group for an ester. So here's our ester group right here that identifies it this. So these two things got added together. Fermentation is another one. That's when enzymatic breakdown of sugar into ethanol and CO2. So you're going to identify alcohol and CO2 as a product. Remember, alcohols have OH as a functional group. Okay, and so in this we have an OH, so we have an alcohol here, and then we have carbon dioxide. Saponification, that's the hydrolysis of fats using a base to produce soap or glycerol, which is an alcohol. So you're going to identify the soap as the product and the base as the reactant. So we have a base here, and we're producing a soap or a glycerol here. Polymerization, that's the formation of a long chain molecule or polymers from small repeating subunits, which are called monomers. They can be natural proteins or artificial plastics. Starch, proteins, and cellulose all are going to be made of repeating chains of, for starch, it's going to be sugars. Proteins, it's going to be amino acids. And cellulose, it's going to be made of repeating units of a sugar. So adding polymerization. So addition polymerization is when you add small alkenes together by breaking the double bond to create a large chain. And that's going to be identified by N, which represents the numbers. So this represents the polymerization of ethylene into polyethylene. So identify by repeating subunits or monomers creating giant molecules. So our monomer would be our smaller part. That will be ethylene plus another monomer, ethylene, plus another monomer, which would be ethylene. And that will make a polymer. And that will be polyethylene because we added all of these ethylenes together and made a long chain. Condensation polymerization, that's joining two molecules by removing water. So if we look right here, we have an OH group here and an H here. These are going to bond together to make water. And then where that bond was broken, the two other compounds are going to join together. And cracking, that's breaking large hydrocarbons into smaller chains by heating them. Fossil fuels are cracked into many components such as octane for gasoline, propane, or etc. So identify the type of reaction in the following. Pause the video and unpause when you're ready. Okay, what did you come up with? Well, if you look, you have ethane here plus CO2, so you're having an addition reaction. What about this reaction? Pause the video, unpause when you're ready. Great, well, welcome back. What did you have here? Again, here you had another addition reaction because these two came together and made one big molecule. Now let's look at this, check your understanding tomorrow, first thing in class.